In this tutorial, we will talk about homologous series. A homologous series is a family of organic compounds with the same functional group but different carbon chain length. So we will have the same functional group, which may be alkanes, alkenes, alcohols, carboxylic acids, or any other functional group. And the only difference between this series will be in the carbon chain length, which means that we will have different numbers of carbon atoms in this group. Let's take an example. Alkanes are an example of a homologous series. Members of a homologous series will have a general formula. Let's write the molecular formula of these alkanes. CH4, remember that the molecular formula shows only the type and number of each atom present in the molecule. C2H6, C3H8, C4H10, C5H12, C6H14, C7H16, C8H18. So we can find that the general formula of alkanes is CnH2n plus 2, where n is the number of the carbon atoms. So for example, if we take hexane, we have 6 carbon atoms. So C6H, 2 times 6 plus 2. So 12 plus 2, which is 14. On the other hand, the general formula of alkenes with one double bond is CnH2n. So for example, ethene has a molecular formula of C2H4. If we examine members of the series, we will find that each member differs from the next by a CH2 group. So the difference between these two is a CH2 group. The difference between these two is a CH2 group as well. The length of the carbon chain has little effect on the chemical reactivity of the functional group, whereas it affects physical properties such as melting point, boiling point, and solubility. Melting points and boiling points increase by a small amount as the number of carbon atoms in the chain increases. And this is because the intermolecular forces increase. So in general, small molecules will be gases, larger ones will be liquids or even solids. So the difference in the boiling point between propane and pentane is small, and this is because the intermolecular forces increase. Chain branching, so if we have side chains or branches in the molecule, will generally reduce the melting points because the molecules will pack together less well. So it will become easier to separate the molecules from each other. And this explains why the melting points and boiling points decrease.